Hello, YouTube learners. This is Dr. Singhal from El Camino College, Torrance, California. I'm a professor of computer science. First of all, I want to thank YouTube for allowing me to host these videos, which has helped people all around the world. Today I'm going to talk about integer division and modulus in C++. First, I want to review data types which are involved in this video and the terminologies. Basically, we have integral data types that can only store whole numbers, and these in C++ are called short, int, long, long, and char. Some people call it char. Char, though stores character, has an integral value associated with it. Those are called ASCII value. Like uppercase A will have ASCII value of 65, uppercase B will have 66, lowercase a will have 97, and so on. And then the other data type is floating data type, floating point, that can store all numeric numbers, whether they are whole or non-whole. And these in C++ float, double, and long double. And since division operator works only on numeric types, I'm only reviewing those. This is not a comprehensive review of all data types. And another terminology, the numerator in a fraction, numerator is the top portion of a fraction. Denominator is the bottom part of a fraction. So, and in a number such as 10.5, the part 10 is called characteristic and 5 is called mantissa. So all these terminologies will be used in this video. So if you don't understand them, pause the video and review them before you go on. Okay. So we want to talk about polymorphic nature of division operator in C++. Polymorphic means something that has more than one form. It has one form in one situation and changes to another form in another situation. Okay. Some newbie C++ programmers have hard time understanding and coping with the polymorphic nature of C++ division operator. This also has to do with not getting a firm grasp on how purely integral expressions are evaluated by the computer. Purely integral expressions would be those who have integers only, and integers are operated with binary or unary arithmetical operators. In this video, we try to throw some light on these topics. Well, we want to talk about nature of integer arithmetic as it is done in C++ by the computer. First and foremost, it is important to understand that when an arithmetical expression comprises only of integral data, C++ is designed to produce an integral result from such an expression. That's one design constant that you should keep in mind. If you have number of integers in an expression operated by operators such as plus, minus, multiply, divide, and something called modulus we will talk about later. Well, C++ is designed that never produce a non-integral result from such an expression. This was done because arithmetic involving integers can be done much faster compared to expressions that involve floating point. or numbers. Floating point means the numbers that contain decimalized fractions. Not only that, integral arithmetical expressions that culminate in integral or whole number results has many practical applications. That's why this was done. So let's look at the integer division Enigma now. Okay, so your math teacher may have taught you that 1.5 is equal to 0.5. But 1 and 2 are both integer. If computer is taught that the result of an arithmetical operation on integer should only evaluate to another integer, then this result is wrong because 0.5 is not an integer. 1 is integer, 2 is an integer. Computer is taught that if 1 is to be divided by 2, the result should only be integer. So what is half in C++? Let's find out, and bunch of other integer divisions, and we're going to look at that in our compiler Xcode. So let's go to the compiler. Here's our compiler Xcode, and I'm outputting 1 by 2 here. 1 is integer, 2 integer, 2 is an integer. And then I'm outputting 11 by 4. 11 is an integer, 4 is an integer. So let's run this program and see what we get. And basically we get 0 for 1 by 2 and 2 for 11 by 4. If I comment that out, I'll just get the first result, which is 0. So 1.5 is 0. If I comment that out, comment that in, then 11 by 4 is 2. Okay, let's go back to our PowerPoint after remembering these results. So let's interpret what we just saw in the compiler. So you saw that in C++, 1.5 evaluated to 0, and 11 by 4 evaluated to 2. In above evaluation, the computer was taught to do old-fashioned longhand division, where quotient is computed until remainder is smaller than the denominator. Okay, so this is how we do longhand division of 1 divided by 2 in C++. That here's my denominator, 1 at the bottom, this one. Here's my numerator, 1 on the top, this one. So since this is bigger than 1, I can only go 0 times. 0 multiplied by 2 will be 0. So 1 minus 0 will be 1. So I get a remainder, and quotient is 0. Okay. So since I got, as you saw in the compiler, let's go back to the compiler again. Let's do this one again. That 1 divided by 2 was 0. That means that integer division truncates the remainder to 0 and only gives us the quotient. Okay. Integer division is designed to truncate the remainder to 0, and it only gives the quotient of the longhand division operation. Thus, 1.5 will be 0, and 11 by 4 will be 2, because if you go on 11 with 4, you can only go twice, that will be 3. And the remainder, sorry, that will be 2, and remainder 3 will be truncated to 0. Okay? And I have this poster that I like to show. I guess I don't have it here. Okay, I'll show it to you some other time. But basically, truncation of remainder is done and only quotient is provided. when we do integer division. In conclusion, one conclusion we can draw is that apart from that, another conclusion we can draw is that when denominator is larger than the numerator, and both are integer, that in C++ the result of division will always be 0. If one at the bottom is always larger than the one at the top, then C++ will give your division equal to 0. Okay? So try some of these things, different expressions in your compiler, and see what results are produced. That way you will have better practice of this concept. All right? But now we want to talk about normal behavior of division operator. Normal means the one that you are used to so far in math classes. And that is when either numerator or denominator or both are floating point types, then you see that normal behavior that you have seen in mathematics all your life. Thus, the below all three will evaluate to 0.5. I can say 1.0 divided by 2. C++ will evaluate that to 0.5. I can say 1 divided by 2.0, and that will evaluate to 0.5 also. And I can say 1.0 divided by 2.0, that will also evaluate to 0.5. I can show that to you in our compiler code blocks. Let's see. So I'm just going to put 1.0 and just kind of copy and paste it 2 more times. 1 divided by 2.0, and finally both can be floating point type. 1.0 divided by 2.0, and we compile it, and you can see that all three produce 0.5. Okay, so the conclusion is that as long as one of the operand to the division operator is floating point type, or both are floating point type, then you get the floating point result. Okay, and the way it does that is that if you have a mixed expression, like this is a mixed expression where you have floating point mixed by the integral expression, integral data. Basically, this is promoted to floating point type, to 2.0, and then that's what it is done actually. The separate video would be for numeric promotion in mixed expression. We won't talk about that here too much. But that's pretty much how it's done. Okay. So this is the summary of polymorphic behavior of division operator. It truncates the remainder to 0 when both numerator, the one at the top, and denominator, one at the bottom, are integral data type. But it gives you expected calculator type results, including the characteristic, that is 1 before decimal point, and the mantissa, that is 1 after the decimal point, when either numerator or denominator or both are floating point type. Okay, this you are familiar with. This is probably something new. So if you remember both of them at the same time, then you should not have any problem understanding the polymorphic behavior of division operator. Okay. Next, we want to talk about modulus operators. This is something that many of you might not have used or heard before. Make sure that you always view this symbol, which you know as a percent, as modulus in C++, as modulus operator. In fact, if you talk about C++, never say percent for this symbol. It's percent in math, but it's modulus in arithmetical operations in C++. In C++, modulus operator is applicable only when both two operands, numerator and denominator, are integral type. Okay. Applying modulus operator when either numerator or denominator are floating point type is a compile error. That'll give you an error in your code. We can show that to you in Xcode right now to confirm that. So we will comment that out. Structure, comment selection, and if I type cout 11.2 modulus 2, for example, well, I got this red dot here. If I click here, it says invalid operands to binary expression, double and double. Of course, this is not a double, but basically saying that you cannot apply modulus operator to floating point data. Okay, I'm going to go back and remove that. Modulus operator is applied as below. We can say int mod, that means we are creating a memory location called mod, which is integer type, 1 modulus 2. And the separation between numbers and modulus operator does not matter. Okay. In process of computing modulus, computer again performs the longhand division, but this time it only reports the remainder, and the quotient is truncated to 0. And the earlier slide that we used for longhand division, we want to show you that again. Okay, so longhand division, this should have been 1 modulus 2. Let's fix that as a matter of fact right now. So once again, when you take modulus of one integer modulus the another one, you again perform the longhand division, which is this here, that we are dividing 1 by 2. But since denominator is larger than the numerator, we can only go 0 times. 0 multiplied by 2 will be 0, so remainder is 1. But this time, quotient, of course, was already 0, so we don't need to truncate that. Only the remainder is reported. Okay. So that's why in C++, 1 modulus 2 will evaluate to 0, to 1. Right now, I want you to pause the video if you want to, and if you're playing with the compiler at the same time, I want you to type number of modulus expressions and see what result you get. Okay, we will do that in Xcode. So let's do the next code. So first I'm going to do modulus cout 1 modulus 2, and it'll be better if I just do one at a time, so this output area is not crowded actually. So do that, and as you can see, 1 modulus 2 showed it to be 1. But if I make it 4, well, 4 is exactly divisible by 2, so remainder should be 0 in that case, and I should get a 0 here as well. And indeed I get 0, because when you do longhand division, 4 divided by 2, 2 is going to go on to 4 exactly twice, so remainder is 0 in that case, so remainder is 0. But let's make this 3, and actually let's make it 4. What did I do? Delete that. Make it 4. and make it 11, for example. So 4 can go on 11 twice, which will be 8. So remainder I should get this time should be 3. And indeed, I get the remainder of 3. Okay? And I already showed you that doing modulus on when either numerator or denominator is a floating point type, that's going to give you a compiled error. That's illegal in C++. That, having said that, if you do have to at some time find the modulus of floating point number, there's a function called fmod that can be used for that purpose. And fmod is applied as follows. First of all, of course, you have to include CMath. But after that, you can do something like this. The double result equal to fmod 5.2, 2.0. That means this is the numerator, this is the denominator. And let's see, I could, as a matter of fact, copy this and show you in the Xcode exactly. I suppose we can put it directly here. No, actually I can't. There's a double data type there. But I could print the result here actually. So let's see what this comes up, but let's do some hand calculation. So 2 is going to go on to 5.2 twice. That's 4.0. So the remainder should be 1.2. Let's see if we get 1.2 or not. And indeed, we get the 1.2 stored in result, and result is then outputted. So if you absolutely have to do modulus of floating point numbers, then you can use this fmod function. But this will not work without CMath include. And Visual Studio, I think today includes CMath by default, but always still included because your program will not compile, for example, in Xcode or other compilers, unless CMath is included in order to use fmod. Okay? So we showed that in Xcode. All right, we did that already. This is the summary of modulus operator in C++. Modulus operator is only applicable to numerator and denominator both being integral data type. Modulus operation performs the longhand division and only reports the remainder while truncating the quotient to 0. An fmod function using number includes CMath can be used to determine the modulus of floating point numbers if needed. All right. And that is the end. Thanks for watching. This is Dr. Singhal, Professor of Computer Science at El Camino College in Torrance, California. Goodbye. Okay, I think